Hello again, guys. We are back in 11.4 on discussing parallel and perpendicular lines and their relationships and looking at a few of our theorems, and on a couple of these we're going to prove why the theorem holds true. So if we start here with Theorem 13, it's talking about if two lines are parallel to the same line, then they are parallel to each other. So I'm going to color code this just a bit. So if A is parallel to B and B is parallel to C, then that lets us know that A must be parallel to C. So our Theorem 14 then starts with if in a plane, because we have to discuss these in the same plane, because like we looked at in our last lesson, if we are non-coplanar, that makes things somewhat confusing. So in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Because obviously if this transversal T has congruent angles in the same location, those corresponding angles are the same, then these two lines must be parallel, as we just saw in lesson 11.3. So by knowing those two right angles, which make it perpendicular, that allows us to know that M is parallel to N. And then you have the proof that justifies this already written out in your notes, but essentially it just walks through that if angle 1 and angle 2 are right angles, then that makes S and R both perpendicular to line T, and therefore if they're both perpendicular to the same line, then R and S must be parallel. Now, understanding how lines have parallel and perpendicular relationships can help us when we get into spatial reasoning. So if you think about each of these pieces on your notes being separate, how could you manipulate these pieces to form a picture frame with opposite sides that are parallel? So you'd want just a rectangular picture frame. So pause the video and go ahead, try to sketch out what you think it would look like. Hopefully you thought of moving the pieces around to something like this, where I put my 30-degree angle with my 60-degree angle because they are complementary, and then when I would attach all of this together, I would get a nice rectangular picture frame. Looks like it would be a bit thicker on the top and the bottom than on the left and the right, but it would still have opposite sides that were parallel. So theorems 13 and 14 we're discussing when we have parallel relationships and or both perpendicular, but now we look at the perpendicular transversal theorem, which shows that if a transversal of two lines is perpendicular to one of my lines, so we see that N is perpendicular to L, so we have lines N right here and line L right here. Those lines are perpendicular, and sorry about the highlighter kind of angle there. And if I know that line L is parallel to line M, then I can conclude that N also must be perpendicular to M because they have the same angle relationship because of that perpendicular parallel relationship. Alright, so there I've kind of got it color-coded for you. And we will be working through these proofs here. So if you want to go ahead and check out example 2 on your notes, go ahead and try to complete that proof. If you're not aware of what I'm discussing, here's the problem. So we have that the given is that L is parallel to K and M is parallel to K, and we want to prove that L is parallel to M. So this is proving our Theorem 13. So go ahead and identify everything that you have. I like to kind of highlight things so it helps my brain, and then I attack the problem. So now I've got things color-coded. I tried to keep it a little clean here. So our given is the yellow and the green. So our parallel line, so we know that K is parallel to L and that K is parallel to M. Then I want to prove L being parallel to M. So again, this is our Theorem 13. We're assuming that we don't know it yet. We have to prove it. So we kind of have filled out some of this, and we have holes for you to fill in. Since L is parallel to K, our two lines here, we know that angle 1 and angle 2 will be congruent by what theorem? And that is then our corresponding angles theorem. And of course, it's corresponding angles of parallel lines. Most of the situations we have now are two lines that we're dealing with will be parallel. So then B, go ahead and look at that. What is congruent to what then? Now, one thing to pay attention to here is that it says for the same reason. So that same reason is our corresponding angles. So of course it's angle 1 and 3 are also corresponding. So they are also congruent. So then by the transitive property of congruence, angle 2 is congruent to angle 3 because I can set up the whole relationship. and then think about what would go into D to finish out our proof. And D would then actually be the converse of corresponding angles theorem, because remember, if we know that corresponding angles of a linear pair are congruent, then that linear pair, K and L here, or sorry, L and M, would then have to be parallel. So our transitive property said that if 1 and 2 are congruent and 1 and 3 are congruent, then 2 and 3 must be congruent, which allows L to be parallel to M. Wanted to point out really quick, yes, I got redundant here on purpose. It said theorem up here, but I wanted to point out THRM is a way that us mathematicians abbreviate theorem. So if you ever see THRM, that is normally representative of the word theorem. So then you want to try example 3 on your own, so you're going to need to pause the video here in a second. I've color-coded everything here from the given. So we have A perpendicular to B, so they make a right angle. B is also perpendicular to C, so they make a right angle. And we also know that line C is parallel to line D by my nice little arrow marks here. So go ahead, try to write a paragraph proof. All you have to do is write out what you're trying to say and why you're allowed to say that. Try to make it nice and concise, and then come back for the answer. I'm going to type out the whole answer and then discuss it, so pause the video right now. Alright, here we go. Since we know that line A and line C are both parallel to the same line B, that then tells us that line A and C must be parallel. Sorry, I said parallel, meant perpendicular. They are both perpendicular to the same line B, then they must be parallel to each other, A being parallel to C, and that's based on, in a plane, if two lines are perpendicular to the same line, they are parallel. So then it's given to us that C is parallel to D, and therefore if A is parallel to C and C is parallel to D, then A must be parallel to D because that reason just stated. So that is all I really have for you guys on this lesson. It was a quick video, so hopefully you understood everything. Please let me know if you did not. Please make sure you work through the entire Pearson module and understand that, and then work on your practice work, and I will see you guys in class. Have a great day.